everybody. My name is Braulio Martinez. I'm a software engineer. That's me in Twitter, GitHub, and Mastodon. I'm also a co-founder of Cedarcode. We're a team of engineers that help other teams of engineers from different companies grow their teams in size and expertise. We have a special passion for security-related things at Cedarcode, so that's why I'm here today to talk to you about Passkeys authentication. Let's begin by why something like Passkeys was given birth. This is the rest of the agenda. Anyone that wants to design an authentication system basically needs to think about the so-called authentication factors, right? And there's ideally there's three categories of them, and ideally for a good authentication system you need to use the three of them. The first one are knowledge factors. And the most common ones we know are passwords or pins. Possession factors, it's something you have. And for example, we can think about a banking card or a USB key. And the third one, it's inherent factors, which is something you are. Maybe your fingerprint or your voice or your face. A common example for an authentication system is, for example, an ATM. For that, we use a banking card as a possession factor, and of course, a 4-digit PIN as a knowledge one. Another example could be the WhatsApp authentication. And for that, we use a possession factor, the main one, the ownership of the phone number, and then we might optionally use a 6-digit PIN as a knowledge one. But the most common authentication factors since the early days, it's passwords. And passwords have a lot of problems. They are prone to phishing, they are prone to brute force attacks. When a hacker gets access to a database or a server, all the user base is compromised at the same time. Users also tend to repeat passwords across different systems, which complicates things a lot for them. And at the end of the day, they are really bad UX for users that need to choose certain patterns, confirm their accounts, rotate them when breaches happen. For developers, we need to encrypt them right, we need to take them out of the logs, etc., etc. A good number I pulled a few days ago is that in 2025, 2 billion credentials were leaked. From those, 70% of the users also used those credentials in other systems. But okay, nowadays we got also a lot of people using two-factor authentication methods, right? You got, for example, one-time passwords that are delivered over SMSs. You also got things like time-based OTPs through Google Authenticator, Auth, whatever you want to use, or physical key fobs, maybe. They are also prone to many different types of attacks, same way as passwords, of course, phishing attacks. SMSs can be attacked through network attacks, SIM card swapping, time-based OTPs, for example, can be attacked through hijacking, getting the QR code you use to set up the method, for example. There's another attack, a great attack called server clock freezing, where you grab one single code and it's valid for eternity. Again, they are discouraged in different ways too, especially the SMS one. That's the most vulnerable one. But nowadays, we got a better usage of second factors. People is more used to setting up a second factor. 64% is the last number I could get from 2024. Another great number is that 90% of all organizations by 2024 had suffered at least one phishing attack. And in the ones that succeeded, the average cost for those organizations was almost $5 million. The most common attack we see being used for these traditional authentication factors is probably the phishing and replay attacks, or the attack in the middle type of attack. Let's say again, to walk you through an example, let's say I get an email, it's asking me to do something, and for that I'm gonna be asked to log into Google. I come here, looks legit, I go in, put my email, password, I use a second authentication factor, so it's all good. If I take a really close look, the URL up there was fakegoogle.com. So if the attacker is good, they're gonna create a great website, and you're gonna fall into an attack like this, where everything is gonna get replayed and your account will get hijacked. I went too far. No, good. Okay. I want to talk about the difference we are seeing nowadays with the AI world and the type of attacks. The traditional vectors are now like supercharged. What used to take weeks and a lot of human effort, like creating good emails, doing phishing attacks that creates good websites, social engineering, it's all done in the matter of now it's machine speed and scale. So what it used to be an urgency on coming up with better authentication factors, it's not theoretical anymore. And the fundamental problem, in my opinion, with all traditional authentication factors, it's that they require human judgment when you're using them. It requires a human to understand that that's not the real site, for example. So that's why something like Passkeys came up. And to talk about Passkeys, we first need to talk about what's like the engines behind Passkeys, what's the predecessor of Passkeys, and that's WebAuthn. And to me, WebAuthn, well, the definition of WebAuthn, it's in the standard and it's a long block of words. To me, trying to simplify that for you guys, it's a standard that defines a set of rules for APIs to enable users to strongly register and authenticate on applications using public key-based cryptography. The folks that created it were the W3C and the FIDO Alliance. The FIDO Alliance is an organization that was created in 2012 to remove the reliance on passwords, and it's formed by major companies, many more than the ones that show up here, but it's just to paint the picture. The standardization process was long and started in 2016 with a draft, went on until 2019 when it became a standard level 1, standard level 2 in 2021, and right now we are almost at standard level 3. There's already a candidate in place. People collaborate on this standard in this repo. It's pretty straightforward to go see what's going on, chime in wherever you want. And okay, now let's talk a little bit about how it works under the hood. WebAuthn provides mainly a possession factor, right? It's the possession of what? It's the possession of a physical device. It's the possession of a USB key. It's the possession of a device like a phone that runs an operating system like a phone or a laptop. And the spec, it's a long document, but trying to make it simple for you, defines these 3 things. What's called a WebAuthn credential, 3 entities, and 2 user flows. The WebAuthn credential, it's a good old-fashioned private public keeper with certain properties. First one, it's strong. It's as strong as the algorithms used in the creation of that public private keeper. And in consequence, it cannot be brute force. The second one is that its scope, and in the same way as, for example, browsers, the cookies on browsers are scoped by domain, WebAuthn credentials work exactly the same. They are scoped by origin. That's how it's called in the standard. And third, they provide digital signatures, and this is what allows somebody to prove that they own a specific device. The entities are free in the architecture of WebAuthn: the authenticator, the client, and the relying party. In plain English, it's the authenticator is the user device, security keys, the phones, the laptops, that create and hold the credentials and do the signing. The client, it's the web browsers on native APIs in the case of mobile, and relying parties, it's our Ruby servers. The user flows are 2. They're called attestation and registration in the standard. Attestation and assertion in the standard. They are analogous to the registration of a credential and the authentication of a credential. Let's see how those ceremonies, how those processes work. The registration we're going to use this diagram to walk it through it. Starts when a user signals that they want to register a credential in a website. That will go to the server where we'll pull a bunch of options from it. Some things like there's a challenge in place, which is a long token used for tampering purposes. The potential algorithms that can be used for the creation of that credentials, many options are going to come from the server. That's going to be returned to the website, to the browser. The browser is going to call the authenticator. Let's say it's a YubiKey, for example, and the authenticator will ask the user for acknowledgement or the actual approval of that ceremony. The user will do so, and in that case, a credential will be created. That credential, alongside the public key, will be forwarded back to the browser and back to the server. The server will need to perform validations over that newly created credential, and if it checks out, the ceremony is done. Authentication is pretty similar. The user starts the ceremony, we pull a bunch of options, and now again, a challenge or a token that is being used for tampering purposes from the server. To the browser, the user needs to acknowledge the ceremony, and a signed payload of a credential will be forwarded back to the browser and then back to the server. The server will need to make sure that the provided signed payload checks out with the public key that was already stored for that user. And if that's the case, also the origin needs to be validated. So that means that the credential was created for the same domain as the actual server that it's doing the validation. If everything checks out, the ceremony is done. The code that's working, that we need to do to actually implement all this standard, it's a long set of steps that need to be performed in the server side, so in the relying party. It's like 20 steps, cryptographic stuff, decomposing complex objects and parsing a lot of data. If you want to do it, be my guest. Else, I encourage you to use the gem we started in like 2018 that does all that heavy lifting for you. Using it will be very simple. You just need to add it to the gem file. You can configure a lot of things. Again, the crypto algorithms that you allow, other things. But the most basic thing, it's the origin, so the domain of your app. Registration in code will look something like this. The user will initiate the ceremony through a form or whatever action you decide. That needs to hit the server. The gem will provide you with an API to get all the options you need. It will even create the challenge for you. The only thing you need to decide, basically, it's where do you want to store that challenge so you can use it to compare it at the end of the life cycle of the ceremony. All that payload is all those options, and that payload will be forwarded to the browser, who will create the native WebAuthn API, which is Navigator Credentials to create. That will prompt the user for the acceptance of the ceremony, and if the user does, everything will be forwarded back to the server, where this other call needs to be performed. You need to grab that credential that came from the authenticator, decompose it, verify with all those 20 steps I mentioned, and if it checks out, you will need to store that credential alongside the user with the public key that came in with it and the credential ID for future usage. Authentication is pretty similar. User starts the ceremony through whatever form you decide or from an action you decide. You will need to pull all the options from the server with options for get. That's the other API endpoint to get the options for the other ceremony. You will need to store the challenge, and then for all of that to the browser. The browser now will use a different API method from the WebAuthn API called Navigator Credentials Get. And an important note is that we will need to pass the credentials that were already registered, the ID of the credentials already registered for that user when we are talking about authentication. If everything checks out and the user accepts the ceremony, all of that will be forwarded back to the server, who will perform all the necessary, decompose the credential and then perform the necessary validations using the already stored public key for that user. Most cases so far we have seen out there, we have been seeing WebAuthn as a second factor, basically, being password the dominant authentication factor still, and using WebAuthn as second stronger authentication factor as a possession factor. But the WebAuthn spec has an optional parameter you can pass in, which enforces the hardware device, the authenticator, to perform what's called user verification. So basically to verify that the user is who they say they are. And that can be done through the face ID, or your fingerprint, or an adherence factor, or if you are using a YubiKey, maybe it can be done through a PIN for that YubiKey. You can set up a PIN for a YubiKey. The API call changes just slightly. You need to add that extra option, user verification required. When you do that, you are actually adding another authentication factor to the process. That might be a knowledge or an adherence factor. And for most consumer apps, this might be too much, right? So if we are going to remove, we might think about removing one authentication factor, but if we're going to remove one, why not removing the weakest one? And that will leave us with just WebAuthn. We have gone passwordless in that context, basically. This is something important I wanted to note, that in this new world, the user gesture, the acknowledgement of the ceremonies, it's not something that AI agents can fake. And that's, in the new world, that's very important. They won't be able to impersonate us. It's where we draw the line. And it's with new scams and new type of attacks coming up, being AI agents relevant in those attacks, this is a technology that will save us from that. Okay, let's talk a little bit about adoption. The early days of WebAuthn weren't that easy, and that's probably, if you haven't heard about it, that's probably why adoption is still something that's being worked on for the last few years. The early days were tougher. There were fundamentally two problems that I want to talk about. Portability across devices was one of them. If you use your YubiKey, it wasn't easy to maybe log in your phone, or if you were using your phone, it wasn't easy to use it on your laptop. If you lost any of those devices and you didn't have a backup, there was pretty much no way of recovering your accounts, so that was a real problem. So the folks that were working on this standard, the FIDO Alliance, at some point said, how can we solve this type of problems and many more for mass adoption? And the answer of that was Passkeys. Passkeys came up in May 2022. The companies that work on the operating systems, Apple, Google, Microsoft, in the context of the FIDO Alliance, made a big swing, and they kind of branded WebAuthn credentials into something called Passkeys, relatable to the password term on purpose. They are not exactly the same. Passkeys are WebAuthn credentials with a subset of properties that we'll see right away. Again, a Passkey, it's a WebAuthn credential in its core, but with the property, the most important property is that it's discoverable. And that means that in the context of a user input, for example, you don't need the actual information about who's authenticating. If the authenticator is available in that specific context, the Passkey will be discoverable. It will show you all the options, all the options you got available to actually authenticate for that site in the hardware device. They also have the property, or you can actually make them multi-device, sync them across devices through cloud services. In iCloud, for example, if you use Apple's password manager, or if you use 1Password, you are syncing them in the password manager. And also, passkeys have a bunch of other great features. Some of them being the auto-filling of them when you are when you see the username and password inputs, and they are suggested by password managers or the Apple autofill features. There's flags in them that tell the server if they are backed up or not, so the server can enforce fallbacks in case they are not backed up. There's cross-device authentication now, so you can use a device to authenticate in another one. Many more features that I invite you to go through the slides later and check out that were a great push and gave us the necessary context to create the mass adoption. Now, you might be asking yourself, okay, but we are now syncing them to the cloud. Is that as secure as the good old-fashioned WebAuthn credentials that were just locked into a hardware device? And the answer is no, they are not as secure. But we are making a compromise with an authentication factor that is way better than all the ones that existed so far. And making this security compromise of actually depending on the security set up in those cloud accounts, is a step in the right direction. It was the only way for us developers to push mass adoption of passkeys. I want to show you how if you haven't ever used a passkey, I'm going to show you a flow. It's called the hybrid flow. It's one of the most elaborated flows you can go through when you use passkeys, but I chose that one on purpose so you can take a look at how it goes. This is our demo, a very simple demo app we have set up. I'm going to register a credential first. Going to just choose a nickname for the credential and start the process. I'm going to choose to use another device, not the computer that I registered these credentials in. So I'm going to use my phone to create the passkey. And for that, I will need to use the camera of my phone. The operating system will recognize that I'm trying to register a passkey and request user verification from me, so my Face ID. Both devices are communicated using Bluetooth, so BLE technically, and the ceremony, it's done. The authentication looks pretty similar. I'm gonna tell the system who I am. I didn't leverage the discoverable credential in this case, but I'm gonna use my phone to authenticate with the credential that I already created from it. Again, user verification will be performed, my Face ID will be requested to unlock the usage of the credential, and that's it. In the early days when we started, basically only Firefox and security keys were an option to test WebAuthn out, but then by October 2019, things look way better in terms of browser implementation of the WebAuthn APIs. Nowadays, and since 2023, all browsers implement the WebAuthn APIs, which is great. The features that I show you are supported in most environments, and there's a few exceptions, of course, but adoption is quite good in terms of infrastructure. Companies and apps that already adopted passkeys are many. I just listed a few of them for you to understand that this is not experimental anymore. This is adopted technology. I even listed a couple of companies on the bottom that use them on their products that they are identity providers. They are used to authenticate US government, personnel, and military people, for example. I especially chose this one to show you, given I'm in Brazil, because I'm not Brazilian, but I'm really proud of this, at least being a Latin American example. In February last year, in 2025, the central bank here in Brazil released in what was called PIX JSR, so no redirection journey. I'm not going to say it in Portuguese. The usage of passkeys in the context of e-commerce, and it was the first example, and only yesterday I saw a new example done by Visa, which is Visa. I don't remember the name. It's a system done by Visa, and PIX it's an awesome example. It uses Passkey to power the acceptance of transactions with your banks. And it's done by the payment initiator, so the payment processor, basically. You register a Passkey with a payment processor, and you authorize the bank. You authorize that payment processor to your bank in only the enrollment of the Passkey. And then from then on, you can use that Passkey with that payment processor for any merchant that uses the same payment processor. I'm sure that you're pretty used to this in your daily lives and just approving transactions and purchases with your Face ID or your fingerprints. To me, it's really cool. We don't, like in the rest of the world, I don't think they have this level of adoption countrywide. So I think you should be really proud. I want to encourage you to take the step of trying to, if your app, wherever app you're working on doesn't have Passkey support, I want to leave you with some resources to do so. If you're using Devise, which is still the most adopted authentication framework out there in the Ruby community, we built a Devise extension. It uses WebAuthn-ruby under the hood, and it will provide you with helpers to put passkeys, enrollment, and also to set it up as a first and second factor. The gem, it's as easy. You need to install the gem, run the generator that we have put in there, and migrate. Then configure a couple of new modules in your macro, in your Devise macro, in the resource that you're using to authenticate. Most people use user, and then set up a couple of things in the initializer that we have created for you. What's your allowed origins, so the domain of your app and the name of your app. These are the three helpers that you will need to use depending on the context of your application. If you are using it, going to be allowing passkeys as a first factor, as a second factor, or you want to enroll in whatever part of your application, allow the enrollment of new passkeys. We also have a demo app for that. This is just a blank sheet app that uses the Devise extension to create all the authentication and registration code with very little styling. Looks like this. If you're using Rails 8 authentication, we also have another gem for that. It's a development dependency and uses WebAuthn under the hood and allows you to use WebAuthn-ruby as a first and second factor. That's a blog post actually about it if you want to read it. I also want to note that while I was working on these slides, I saw that Rails, now there's an open pull request in Rails to add built-in adoption of passkeys. So there's an implementation in Rails now that might get upstreamed that for supporting passkeys in Rails, not natively. That might be relevant to you if you are using Rails 8 authentication. Rhoda, now I don't have a slide for it, but I know Igor mentioned Rhoda. Rhoda has been supporting passkeys using WebAuthn-ruby for the last 3 or 4 years maybe. So that's another, we didn't need to do anything to help adoption in the context of Rhoda because Jeremy did it himself, used the WebAuthn-ruby gem himself. We have a couple of demo apps that could also be useful for you. A blank sheet application with Rails and Stimulus that's fully passwordless using WebAuthn-ruby. Another one, if you want to see how it works only as a second factor, again, blank sheet application, Rails and Stimulus, that's it. There's a real-life example we did in 2020. We added it to the Mastodon social network. It uses Devise. So if you want to see how it looks in a Devise environment in a real-life application and all the complexities that it might have, that's a great pull request to take a look at. The future holds a lot of things still to do for us. WebAuthn-ruby, it's in version 3.4.3. and there's a lot of maintenance we need to do for the gem and for all its dependencies, because we got a bunch of other dependencies that that work for WebAuthn and Ruby. The standard, as I said, is still evolving, and new features have been added to it. So we need to keep working on keeping up with the standard. The usage of passkeys in the context of digital credential and identity verification, it's still in development. I went to AuthenticateConf last year, which is a conference only to talk about passkeys and WebAuthn, done by the FIDO Alliance, and there's a lot of work being done in the usage of passkeys together with digital credentials. Also for e-commerce, in the development of another standard that's called secure payment confirmation. Again, Pix, for example, it's already doing pretty much secure payment confirmation without that standard being fully settled. Visa is also exposing a version of SPC. So we are still gonna be taking a look at that, paying attention to that, and see if there's any space for us to add value in the Ruby ecosystem, of course. I'll leave you with a bunch of resources and things if you want to read about it. And that's it. Thank you.